Okay, so we've figured out that there's a million six-digit pins, but one of the rules about these million is you can reuse digits in the pin. So, for example, 112255 is a totally legitimate six-digit pin. What if we couldn't? What if all the digits were different? I've talked to people about this, and some people have themselves convinced that having all different digits is better than having some digits repeated somewhere. And we might talk about that more later in the class. But I decided, okay, well, let's look at it mathematically. Let's try to figure out how many possible ways can you have all the digits different. So let's just work through it. You got 6 numbers you have to pick. Let's say you're creating a brand new pin. And you have to pick the first digit first. Well, there's 10 digits you can pick from, which is great. 10 digits is awesome. Now it's time to pick digit number 2. Well, digit number 2 has to be different than digit number 1, which means you no longer have this 10 choices. You only have 9 choices for digit number 2 if all the digits are going to be different. And then when you get to digit number 3, it can't be the same as digit number 1 or digit number 2. So now you only have 8 choices left. And then when you get to digit number 4, you only have 7 and 6 and 5. So the math is going to look similar in that you're going to have to multiply 6 numbers together, but those numbers are going to have to go down by 1 each time because you're actually minimizing how many numbers you have by 1 each time. And when it works out mathematically, there's only 151,200 pins where all the digits in the pin are different from each other, which is an interesting thing to think about because that's a much smaller number than a million. It's about 7 times smaller, which kind of makes me wonder if the claim having all the digits different is better is actually true. It seems to me that being able to repeat digits might be better in the grand scheme of things. I'm going to offer you at this point, if you want to be done with this video and skip to the next one, you can. I went down a rabbit hole a little bit chasing that last question, that last statement I just made down. So if you want to skip this next part of the video, you're not going to miss anything crucial. But if you want to go down the rabbit hole with me, let's go. So I made up a spreadsheet here, just again, down a rabbit hole, to test the theory about is it more secure or is it better to have all different digits in a pin versus not having all different digits in a pin? And I just made a little table in Excel. If anybody's interested in how to create a table like this, I'd be more than happy to send you tutorials on how to do it. We're going to learn how to do some of this stuff in class together this term. So what I did was I made a table from a 1-digit pin up to a 10-digit pin. And then I figured out how many possible ways you could have a 1-digit pin, a 2-digit pin, a 3-digit pin, if you both could repeat digits or if you couldn't repeat digits. Just did the same math we just did back here on this slide, except I let the number of the digits in the pin change. Some of these numbers are going to look familiar. For example, 4, there were 10,000 possible 4-digit pins, and there were 1,000,000 possible 6-digit pins. If we have all the digits be different, though, there are 151,200 6-digit pins. We didn't figure this one out, but there are 5,040 unique digit pins when there's 4. And then all I did next was I took this number and divided it by this number for each of the numbers. And then it really begins to show you something. Like, as you work your way down the line, there are a lot more ways to create a pin that has at least some of the numbers repeated than ones that don't. Like, for example, for a 4-digit pin, which is the smallest one a cell phone has, there's about twice as many pins available that have at least a number repeated than those that don't. By the time you get to 6, it's 7 times more than this. And if we were to stretch it out to 10, there's 2,756 times more pins that have repeated digits than those that don't. So I would just maybe answer somebody that says their pin on their phone has all distinct digits. I don't know if I agree with that. I think it might be better mathematically to have at least a few digits repeated. Now this is oversimplifying a little bit because this also includes all of these. But at the same time, these numbers are growing much, much, much faster than these numbers are growing. So anyway, that was the rabbit hole I wanted to go down with you, and we'll see you next when we talk about encryption.